Everybody, welcome to my channel. This is part 3, and the previous tutorial we tried to see about completely randomized design. Then it's followed by randomized block design, and in this tutorial we'll continue to compute Latin Square Design using AgroR package. So as usual, you have to import your data. I already imported my data, and my data containing 4 different columns. And the first column is the treatment, which is 4 treatments, maybe it's a variety, A up to D. Then the nature of Latin Square Design is a perfect square as a number of, it's equal to the number of treatments. So we have 4 treatments that we're expecting to have 4 column and 4 row. And this is the row, this means vertical blocking, this one the horizontal blocking, which is considered as row, and column, and here is vertical blocking, and YD stands for the response variable, that means yield. Then the function that helps to compute Latin Square Design is DQL. If you remember, for CRD it is DIC, and for RCBD is DVC, and here is DQL for computing Latin Square. So you have to use a function with and indicate your data name. So our data name is L, and it's followed by the function DQL that helps us to compute Latin Square Design, and followed by the column that contains the treatment, column that contains the row, column that contains the vertical blocking of the column, and then columns that contain the response variable. So in our case it's YD. And ylab is equals to, if you want to give axis title for y direction, so you have to write in this way. And norm is in order to check the normality, and the method I suggest here is SW, which is Shapiro-Wilkes, and you can convert on the basis of your preference, like Anderson, Darling, and Shapiro-Francia, and any other method. And you can refer my first tutorial regarding to completely randomized design. And this homogeneous, it is for checking of homogeneity of variance, which is BT. BT stands for Bartlett test. And here is alpha.f is to specify F table, or the level of significance for F table. The default one is 0.05, but if you are interested, you can convert into 0.01. Again, alpha.t is the level of significance for multiple comparison tests. So that's one is the default one, 0.05. But if you are interested to convert into 0.01, you can do it this way. And this package is only worked if your treatment is qualitative instead of quantitative. So you have to specify, which is again, this one is default to 1. So if it's not qualitative, you have to say false. Multiple comparison is mcomp, which is there are a number of multiple comparisons like tukey, less significant difference, Duncan, and SK. So you can again select what really you want. And here is the geometry to display your result in terms of graph. And if you want to represent in a bar graph, so you have to say bar. If you are interested into box plot, so you have to say box. Then time is, I already show you in my previous tutorial, and sub is, which is the distance between the error as well as the error bar and the letter of significance. And CV is also true. If you say false, the p-value along with coefficient of variation will not display to your graph. But CV is also true. Both p-value as well as the coefficient of variation will be displayed. So textsize help us to increase the size of x-axis as well as y-axis, and as well as the level of the treatment. And here is label size, means if you undergo multiple comparison tests, so the letter A, B, C, D size will be adjusted by doing this function. And fill is equal to light blue. You can change the bar plot color in the basis of your preference, or maybe you can give on the basis of the number of treatment. So that's also is your interest. Addmean is equal to true if you want to display the mean value into box plot or bar plot. So let's say here is false. So false will not display the mean value in the bar plot or box plot. So error bar is equal to true means again it's displaying of the error bar either in our bar plot or box plot. So type this all and submit to our studio. Yeah. So as you can see here, there is a normality test after using the Shapiro quiz test, and the p-value is greater than 0.05. So we will consider either as a normal, and here homogeneity of variance using the Bartlett test. Again, it is greater than 0.05. So still we will consider our variance can be considered as homogeneous for our treatments. Then here is also CV, analysis of variance we are expecting for source of variation. The first one is treatment, then followed by line means it is a row, column it is a column is a vertical blocking, line is a horizontal blocking, a trait is equal to the treatment. So again, here is the multiple comparison test is a tukey significant difference. As you can see here, in the treatment is p-value 0.83, which is not statistically significant. So we not expect a multiple comparison, and the null hypothesis will not be rejected. So again, you can see here the result in. So you can save this final plot using the ggpubr function. So submit this one. Then you can give the file name any name that you want. I give LSD.png in the form of PNG, or you can convert in the form of PDF or a JPG. The width is 15 and the height is 15, and the quality of DPI is equal to 2500, and the units of the width and the height is in centimeter. So you will save this to your document or desktop or any other location. So this is all about today's tutorial regarding to Latin Square Design using AgroR package. So see you soon.